right, so at the Math Forum, we worry a lot about problem solving and kids thinking about math and kids thinking that they can do math. And I'm going to talk a little bit about ways in which we do that. Right? So long ago, sometime in the mid-90s, I was on an airplane and I was flying to Detroit. And I was going to do a sketchpad workshop, okay? So I gave up my window seat to a 3-year-old. And so his dad sat in the middle. It was late at night. The picture should be at night, but I couldn't find one. So, and the kid's looking out the window, and he's going, "Dad, what's that?" And Dad, being a good dad, is answering him. He said, "Oh, it's this, it's this." And this goes on for a while. "What's that?" What's the dad answers. That's great. At some point, Dad apparently wasn't paying attention. And so he says, "What's that, Dad?" And I turned and I said to the kid, "Well, what do you think it is?" And he came. I don't remember what it was, but I know it was profound. And so the rest of the flight went on like that. He's saying, "Oh, what's that?" And we said, "What do you think it is?" And eventually he doesn't ask anymore. He just starts talking about what he's seen out the window, right? And so later on, we're walking through baggage claim, and I went ahead, and they caught up with me, and the guy says to me, "I listened to the way that you talked to my kid, and you really made him think. I'm going to talk to my son differently from now on. Thank you." All right? So, all right, another story. So I'm going and I'm going to do a model problem solving with an 8th grade class, and the teacher says to me, "Now, these are our lowest 8th graders, so don't expect too much." Okay? So I drew this on the board, and I asked them to write down things that they notice about the picture. All right? So they're writing, and they're in some. Then we said, we're going to share some stuff that you notice. All right? So we start gathering things together, and we start recording things on the board. And I know that you are all noticing things because that's what you do, right? You're noticing things about this picture. All right? So we start making a list. So is your thing on this list? Okay? Here's a list of things that they noticed. All right? It's very mathematical. These are kids who cannot do math, remember? Okay? And they've come up with all this mathematics. All right? Their teacher's standing in the back, sort of, picking her job from the floor. So, and there are a couple things on the list that I asked them, "Could you say more about?" So one of them said, "Well, it used to be a square." And so I asked him to come up, and he drew a little box to show what he meant by that. And then another kid said, "Well, it can be split into 2 rectangles." And so he came up, and he drew a line to show us how it could be split into 2 rectangles. For homework, they all got the problem, and they were asked to write down things they remembered. Some of them actually solved the problem, even though they didn't have to. It was about tiles and stuff. And the teacher sent me this excited email like, "My kids actually did mathematics." And I'm like, uh-huh. See, where can we go with that? So another piece to noticing is, can you wonder about things? Can you be curious about things? And instead of asking kids, "What don't you understand?" or "Does anyone have any questions?" ask them what they wonder. It displays curiosity, not misunderstanding. One kid wrote in a journal once, "I'm wondering if fractions only work with circles." Right? That's a whole nother talk. So one thing that we do, you want to stop the kid who you put the problem up, and like 2 seconds later, he's got the answer. So we encourage using what we call a scenario. It's a math story, and it doesn't have a question. All right? So these kids, 9th graders, they're working on a story about the surface area of various shapes, sizes of things. Here's their noticing and wondering sheet, and we're going to listen to a little bit of mathematics on this next thing. They have noticing in one column, wondering on the other. Right?
So we figured out that the length times the width equals 1/12, and the side equals height times width, and the front equals length times height.
And I'm trying to unsquare them to find the... You can't
unsquare them with the rectangular prism.
Okay, so you can come listen in the booth. So another kid, she made lists of the factor pairs, and she figured it out by picking 3 and 16 for the one side, because they're on the 48 list. So that meant this had to be a 28, because that's on the 84 list. And then she got a 16 and a 28, and that wasn't on the 112 list. So she picked another number, and she eventually got it right. And another girl in her group is sitting there, and I said, "Well, what's up?" She says, "Well, I know how she got the lists, but I'm wondering how she knew what to put on the picture." And the other girl then explained it to her, and she really got it, and we gave her credit for that. So in using the noticing and wondering idea with kids, so it provides a platform for kids to connect what they're seeing in the problem with stuff that's already in their head. Right? And it also lets kids know that they have useful math ideas. Max is an example of that, right? And it's a habit of mind, right? You guys, all of you, you're good problem solvers. That picture went up there, you noticed stuff quickly, you applied those ideas, you picked a strategy. They read the problem and they go, "What formula do I use to find the answer?" They don't even know what's in the story. And we're asking them, they think, "I'm going to solve the answer by finding the formula." So one middle school teacher we taught with, their kids did some noticing and wondering, and then one teacher's like, "I didn't know how they knew that because I haven't taught it to them yet." Okay? So how do we help teachers value and make use of things that students notice and wonder? And then the things that I'm wondering is why that kid's dad got it so quickly and how we help teachers get it the same way.